Now we take the question which is given in 2009 IPE. The question is, state the law of conservation of energy and verify it in case of a freely falling body. Tag to this question, a problem is given. A ball is projected vertically upwards from the ground with an initial velocity 9.8 meters per second. Find the maximum height using law of conservation of energy. In this, the question carries 6 marks and the problem carries 2 marks. One thing you remember, if the question is a derivation which is given for the 6 marks, then if you write the statement, you get 1 mark. If you write the theory or concept what you are using for the derivation, that gives 1 mark. The derivation gives 3 marks. The result or limitations, that gives 1 mark, and the problem carries 2 marks. Suppose if I take this question, how to present this question? What is asked in the question is, state the law of conservation of energy. This is first part of your question. That means if you write the statement for the law of conservation of energy, it gives 1 mark to you. The statement is, energy can neither be created nor be destroyed. It can be converted from one form to another form. The total energy remains constant in a closed system. This is law of conservation of energy. Now the concept we are using to verify this in case of freely falling body is, during the motion of a freely falling body, if I consider 3 different points, if I can show the total energy at any point is same, that verifies the law of conservation of energy. This is the concept what we are using here. Next, the derivation is, consider a body of mass m falling freely from height h above the ground, as you are seeing in the figure. Suppose if I take at maximum height, that is at point A, the body has only potential energy. When it is moving from A to B, the potential energy is converting into kinetic energy. At B, the body is having potential energy as well as kinetic energy. Why? Because the body is at some height and also it is having some velocity. When the body reaches the ground, the potential energy equivalent to 0, the kinetic energy is maximum. That means when the body reaches the ground, all its potential energy is converted into kinetic energy. Now we consider at point A, the potential energy is mgh. Here h is the height. At this point, what is the kinetic energy? What is the formula for kinetic energy? Of mv square. For a freely falling body, we know that initial velocity equivalent to 0. Kinetic energy is half m into 0 square. This is equivalent to 0. Now at this position, the total energy, this is equivalent to potential energy plus kinetic energy. This is equivalent to mgh plus 0. This is equivalent to mgh. You take this is equation 1. Now you find what is the energy at B. At B, the body is have both potential and kinetic energy. Let us consider B is the point after traveling a distance x, as you are seeing in the figure. Now this is at a height h minus x. At this position, potential energy is mg into h minus x. This is equivalent to mgh minus mgx. Now at this point, what is kinetic energy? Let us consider the kinetic energy is half mvb square, where vb is the velocity at point B. This is nothing but 2gx. vb equivalent to root of 2gx. How you get this? Using the equation v square minus u square equivalent to 2as. Here s equivalent to x, u equivalent to 0, that is initial velocity. At B, let us consider velocity v equivalent to vb. The acceleration a equivalent to g. From this you get vb square equivalent to 2gx. Just I am substituting these values in equation v square minus u square equivalent to 2as. Therefore, kinetic energy at this point of mvb square, this is equivalent to 1 by 2 into m into 2gx. This is equivalent to mgx. Total energy at this point is sum of potential and kinetic energies. Now this is equivalent to mgh minus mgx plus mgx. Therefore, total energy equivalent to mgh. You take this as equation 2. Now we consider at C. C means when it reaches the ground. When it reaches the ground, what is the energy that it contains? Only kinetic energy. At this point, potential energy equivalent to 0. Why? Because H is equivalent to 0. mg into 0, that equivalent to 0. This is potential energy. Now kinetic energy is half mvc square. Here Vc is nothing but velocity at this point. Again, for Vc, you take the equation V square minus U square equivalent to 2as. Here S is nothing but the total displacement of the body. The displacement traveled is nothing but h. Initial velocity is 0. Final velocity is Vc. Acceleration is acceleration due to gravity. Now if I substitute the values of S, U, V, A in the equation V square minus U square equivalent to 2as, we get Vc square equivalent to 2gh. Therefore, kinetic energy at C is half mvc square, that equivalent to 1 by 2 m into 2gh. Now this is equivalent to mgh. At this point, the total energy is potential energy plus kinetic energy. This is equivalent to 0 plus mgh. This is equivalent to mgh. You take this is equation 3. Now we can write using equation 1, 2 and 3. The energy at A equivalent to energy at B equivalent to energy at C. That means you take any point during the motion of a freely falling body. The total energy is always constant. Hence, the law of conservation of energy is verified. Since energy at A equivalent to energy at B equivalent to energy at C, we take any point during the motion of a freely falling body. The total energy is always constant. Hence, the law of conservation of energy is verified. Now, the conditions of applicability or the limitations of this law is the internal forces should be conservative. The second one is the external forces should not act on it. If any external force is acting, the law is not valid. If these conditions are satisfied, then the total energy remains constant. Now, this is for 6 marks. Now you see this answer. If you write the statement, we get 1 mark. How we are going to prove this? That gives 1 mark to you. The derivation, this gives 3 marks. And these limitations are conditions of applicability. This gives 1 mark. Total 6 marks for this question. Now this is tagged with a problem. The problem is for 2 marks. That problem is a ball is projected vertically upward from ground with an initial velocity 9.8 meters per second. Find the maximum height using law of conservation of energy. Now what is given in your problem? Ball is projected vertically up with initial velocity 9.8 meters per second. At the point of projection, ball has only kinetic energy. This is converted into potential energy at maximum height. According to law of conservation of energy, we can write kinetic energy on ground is equivalent to potential energy at maximum height. Now this is the principle or concept what we are going to use in the problem.